So let's get started. We will start by creating a new Xcode application. Now I am using Xcode beta 9.3 beta 2, but you can use the Xcode 9.2. Now the reason that I'm using 9.3 beta 2 is that my device, the actual physical device, is running the iOS 9.3. But none of the features that we will be using for building our furniture app will be using 9.3 beta 2. So let's go ahead and get started. So you can use Xcode 9.2 and everything will work as expected. I'm going to go ahead and select the augmented reality application. Go ahead and select next, and we will call it maybe furniture app. Next. And now we need to save it somewhere. So I'm going to go to desktop, exercise files, setting up the project, maybe start, or we can actually go to end over here, and I'm just going to save it over there. But obviously you can save it anywhere you like. All right. Now, if I open up the view controller.swift, this is all the default code that Apple has written for me. I don't really need most of this code, so I'm going to delete the session interrupted, the session was interrupted, did fail, this commented out method, and did receive memory warning. So I'm going to delete all of that code because, it's less stuff to look at. And also I'm going to remove the scene that we are loading since we are not loading a ship scene. If you are curious what the ship scene actually looks like, you can open up the art assets and you can look at the ship scene, which consists of a spaceship. Once again, all of this is added for you by default when you create the augmented reality application. So I'm going to remove that reference and remove that part. There we go. Okay, so right now we're creating a scene, but it is an empty scene. It doesn't really have anything. And if you have watched the last video, the last lecture, you know that we need to add some sort of a furniture, maybe a chair, maybe a couch or something. So we need to get that model added to our application. All right. So let's go ahead and I'm going to go to a website called TurboSquid. Now, obviously, this is one of the many websites where you can go and download a particular model. I'm just selecting this because the model that I actually want is available on this website. Now, in order to download the model, you must be logged in. So go ahead, register your account, and log in with your credentials. Once you're logged in, you can simply search for the model. I'm simply going to search chair. And if I enter return key, you can see different kind of models up here. But I really want the model in some special format with some special pricing. So let's first go ahead and set the price. So I'm going to set the price to free model because I don't want to pay for it right now. And you can see that there are so many different models available. All right. Each model will be accompanied with what type of a model it is. You can see most of them are 3D Max models and 3D Max and OBJ and blah, blah, blah. So a lot of different kind of models. I'm going to select the DAE format, which is a Collada format. And I'm going to see that if I can find a model which is suitable for my needs. And I do. Here it is. This is the model that I'm looking for. Now, obviously, you can select any model that you like, but I will be working with the green wooden armchair model. You will also experience that you will face different challenges when working with different kind of models because each model is created by a separate designer, and you will see that you will face different issues when you're working with different models. And even though I'm selecting the green wooden chair model, you will see that I will face some issues with it, and we will see how we can resolve those issues. So let's go ahead and click on this, and you can see the model. You can click on these pictures and see the model in different views. I'm going to go ahead and download the model. So there we go. And since I have already added that model, I can go ahead and download it. You can see that this model is now added to my list of downloads that I can do. I'm going to go ahead and say show all kind of downloads, and these are the different formats that the model is available in. All right. Now the one that I actually want is the DAE, which is a Collada format. So I'm going to download the armchair collada.zip file. Okay, and here we go. It's actually being downloaded, and it has already downloaded. Let's go ahead and open up the zip folder, and a lot of stuff going on, but here we go. So this is the model. If you open up the zip folder, you will find these three different files. The DAE is a Collada file, the main file, and these JPG and JPG, these are just different textures that are applied to the model. Now, select all of these three things and simply drag it into anywhere in your application. Now, you might be tempted to drag it into the art assets folder. You can, but I'm just going to leave that, not dragging it over there for time being. Sometime I have seen that when you have image assets inside the art assets folder, the Xcode kind of crashes and it doesn't work as expected. But right now I have placed it into my furniture app folder. So I have all of these files. Click on the armchair.dae, and on the right pane, click on the file inspector. And make sure that the target membership checkbox is checked, as you can see. And make sure for all of the different files that you actually added. So this is the JPEG, so this is also added. And the final JPEG, which is some sort of a wool kind of a structure, texture, this is also added. So right now, we're good. We have added the DAE files, the JPEG file, and the other JPEG file. All of these files are added, and we are now ready to add this model into our real world as a virtual object. Okay, so now that we have set up our project and we have also added the model, the 3D model of a chair, along with the materials that are used in the 3D model, our next step is to place that 3D virtual model of a chair somewhere into our real world. And that somewhere shouldn't be in the middle of air, right? It shouldn't be like floating. It should be resting on some sort of a surface, like a plane or a floor. So we need to tell the ARKit that, hey, we are looking for planes. We are looking for something that is flat, that is well textured. There's a right amount of light over there, so we can put our virtual objects on top of those things. So the first thing we are going to do is we are going to enable the plane. Configuration.plane detection equals to horizontal. All right. And that's pretty much it. All you need to do to enable the plane detection. This really means that anytime you run the app and you are looking through your iPhone camera on the floor on something horizontal, it's going to detect that as a plane, meaning that is one of those places where you can put your virtual objects. All right. So the question now is that how would you tell the user that, okay, I have found a plane, so go ahead, put some stuff on it. You can't really do when the plane is detected. You will say like print something, right? Plane detected. Well, user is not going to see that, obviously. There is no output window in the AR app that you're running. So the first thing you need to do is you need to find out what happens when a plane is detected. So when a plane is detected, there is a function, a delegate function, which is called a did add. This gets fired whenever a plane is detected. And we can check that if something is AR plane anchor. So this is meaning that we are making sure that the anchor that the ARKit has detected is of type of a plane. It's not some other virtual object that someone has added. Well, it is type of the plane that has been detected by ARKit. But the question still remains, how would you tell the user that you have detected the plane so that the user can take next action, which is hopefully putting a chair on top of a plane? So there are many different ways of doing that. One of the ways I want to show you is by using a library called mbprogress.hud. This library is not at all related to augmented reality. It is basically for iOS applications to display some sort of a message like a loading sign and so on. If I click on one of those, you can see a loading sign over here. So that is what this library actually does. It allows you to easily create a progress heads-up display that can be displayed kind of like this, the center thing that you can see. If you have a favorite library that does that, you can go ahead and use that. This library, it's just a nice thing that we can add to our application so that it can tell the user in a nice way that, hey, I have detected a plane, and now you can start putting on your, chairs and whatever you want to, virtual objects you want to put on the plane. So I have already downloaded it. You can download it by using the green button, which is clone or download, and clicking over here saying downloading the zip file. Once you have downloaded the zip file, you need to add that. So let me go ahead and open up the download folder that I have. I'm going to go inside that folder and I'm going to copy these two files. This is in Objective-C, so don't worry about that. So this is mbprogress.hud header file and mbprogress.hud the implementation file. I'm going to just simply drag those into my project and copy items if needed, create folder references, and everything is good. It's going to ask me that if you want to create a bridging header, meaning you want to communicate between these particular Objective-C files and SIF, I'm going to say yes, sure. And you can see that it has created another file for me, which is called the bridging header. Inside this file, I'm just going to import the file that I just added to my project, which is mbprogress.hud and .h. All right. Once again, you don't really have to do any of these things. This is just something extra that I'm showing you, and you will see that it actually does look really nice, and it tells the user that the plane has been detected, and now they can put some stuff on that particular plane. With that in mind, let's go ahead and create private HUD, which is mbprogress.hud, not this one. So mbprogress.hud, there we go. We do want to fire this whenever basically we load the scene. So let's go ahead and say self.hud .mbprogress.hud.show in self.sceneView animated, yes, true. We do also want to show something to the user, so hud.label.text, and you can say detecting plane. This is basically up to you, whatever you want to say. Detecting a plane. All right. So this is going to enable the HUD, and the HUD, the heads-up display, is going to say detecting the plane. Now, once the plane is detected, which is right over here, we should be able to hide this. All right. So let's go ahead and copy this. Maybe we will change the text to say plane detected, and we can say self.hud.hide after animation. So after, let's say, a delay of 1 second. So then you hide it. And we want to call this in a dispatch queue main.async so that this all of these operations are actually being performed in the main queue, in the UI thread, and not somewhere in the background thread. All right. Once again, all of these things that I'm doing right now, it's not necessary, but it's a very good practice, and it is also recommended by Apple if you read their guidelines for building augmented reality applications, that to show the user, to alert the user that a plane has been detected so that they can take the next step, which in our case will be adding furniture like chair on top of the plane. With these things set up, let's go ahead and run our application to give you an idea of this nice effect and UI and usability that we have actually created for our augmented reality application. Here is our plane detection and mbprogress HUD in action. In the last lecture, we learned that how we can display MB progress HUD control to the user so that the user will know that the plane is being detected and the plane has been detected. Now, this is just a very nice way of telling the user that something is going on and the augmented reality application is in use. And once the plane has been detected, we simply set the message plane detected. You don't really have to do that, but it's a good practice to do this so that the user will know something is going on. Now, what we want to do is we want to tap anywhere on our iPhone, and at that particular location, we want to add a chair model to that particular coordinates. But first, we need to register our gesture recognizer, because right now, if you run the application and if you tap on the screen, nothing's going to happen. So let's go ahead and register gesture recognizers. We're going to create a separate function calling it register gesture recognizers. And I'm going to call it recognizers as a plural because we will be using the same function to register some other gesture recognizers. So let's go ahead and call it register recognizers. There we go. And now inside this function, I can go ahead and register my gesture recognizer. So I'm going to call it tap gesture recognizer because this particular gesture will be fired whenever you are going to tap on the screen. The target is self because we are going to catch it inside the self, which is the instance of the controller. And the selector or the function that is being triggered whenever you tap will be called tapped. Now, we don't really have this function, and you can name this anything you want. We're going to create this function later on. Let's go ahead and say sceneview.add gesture recognizer, and we're going to add the gesture recognizer right here. All right. Now, once we have the gesture recognizer, we need to implement the tapped function. So the first thing is that we need to say Objective-C because the selector is coming from the legacy Objective-C code, and all of these tap gestures are Objective-C functions. So you have to say that, okay, there is a bridge between the tap function and calling the tapped in Objective-C. Recognizer, which in this case will be UI tap gesture recognizer. And there we go. I mean, this is pretty much it. So now if you tap on the screen, you will be able to fire this particular function. Now, what we want to do inside our tap function is to get the coordinates of where the person has actually tapped. All right. So first thing we're going to do is get the view that has been tapped. So we're going to say scene view equals to recognizer.view. And recognizer.view is going to return you some kind of a view. I can cast it like this, or I can even go ahead and I can say simply like this, AR scene view. Now, obviously, if this casting fails, it's all gonna blow up. I mean, this is a kind of like a force kind of a casting that you're doing, and for comparison or forecasting you're doing, that if it fails, it's gonna simply blow up. Now, depending on if you want to do that or not, you can replace it with a guard if you want to, and change that to the optional casting, and then you can say return over here. Okay, so in this case, what it's going to do is if it fails, if the tap thing, the thing that you tap on the screen is not the ARSCN view, then it's simply going to return and not really going to do anything. All right. Now let's go ahead and create another variable called touch, and we're going to say recognizer.location in view. All right. So location in view, we're going to pass in the scene view, and once you pass in the scene view, the recognizer is going to return you the location in a two-dimensional coordinate system. All right. So this is not the coordinate system in the AR world with 3 coordinates x, y, z, but this is the coordinate system that you get from the iPhone screen, which is only x and y axis. So it will be mostly like CG point, as you can see on the documentation on the right hand side. It is a CG point which will consist of the x and y values. Now in the next lecture, I'm going to show you that how you can make sure that the point that you have touched intersects with the plane that you have detected. And that's going to get interesting, because once we have detected the plane, and if we touch on the screen and it is telling us that, okay, the point that you have touched actually is a plane. So now we are sure that we can put some items on that particular plane. All right. So that is what we're going to do in the next lecture. All right. So in the last lecture, we enabled the tap gesture recognizer. We actually added it to the scene view. And we also got the touch location, or the coordinates which are relative to the iPhone screen, which are X and Y coordinates. But we don't really know that if the touch that we have performed is that intersecting, is that touch on the plane that has been laid out by the the ARKit, or is it not? So once we have the touch, we can actually use some of the functions of the scene view to see if the ray that has been emitted by the touch event, you can consider it as kind of like an invisible ray, does that intersect with the plane that has been laid out and detected? All right, and if you remember, we are using the default configuration on line number 76 to detect the horizontal plane. Whenever ARKit is going to find a plane, it is simply going to tell us that, okay, I found a plane. That's pretty much it. And you can consider plane as a horizontal surface. So maybe your carpet or a wooden floor or your desk. All of these are horizontal planes. Okay, so let's go ahead and do that. We're going to use scene view dot hit test. And you'll see that you have multiple options for hit test over here. You have a hit test which takes in types, which is the AR hit test result type. You have a hit test which takes an event, and a hit test of test option, which is a dictionary. We're going to use the first one, pass in the touch wherever we have touched. And the second argument is we're going to pass in what kind of plane, vertical plane, horizontal plane, and so on. So I'm going to say over here, existing plane, and you can see the documentation which says a plane anchor already in the scene detected with the plane detection option without considering the plane size. That's okay for now. We're not really considering the plane size. Now, the hit test function is going to return you, as you can see on the right-hand side documentation, it's going to return you an array of AR hit test result. All right, so let's go ahead and do that. Hit test results. It's an array of hit test results. There we go. Let's actually send this back in. Here we go. Okay, so now we have a hit test results. And what we are going to do is we are going to just take one of those hit test results, basically the first one. All right, so if let hit test, this is just a variable I'm creating, and the hit test results is an array. So I'm going to just take the first one, which is the, if it has the first one, then do this. All right. So if it goes inside these parentheses and if it goes inside the body, we are 100% sure that it has performed the touch that we have done. It has performed an intersection with the plane that we have detected. All right. So now the hit test contains a lot of other information. Let's say you can see the hit test contains the world transform and so on, like many different things it contains. So what we are going to do is we first need to get the model. All right. And if you remember, our model is currently inside the file called armchair01.dae. That's the name of the file. There's a space in the file also. I would like to rename it to something else so that there's no space over here. So I'm going to just call it chair scene or chair file, whatever, just chair.dae should be okay. All right. Let's open this document outline right at the bottom, and you can see that the name of the model is cube_011. Weird kind of a name. Maybe we can replace the name also. Let's go to this node inspector, and you can see that the name of the cube is 0.11. So let's go ahead and name it to, I don't know, chair. Now, this chair has no correspondence with the name of the file, so don't get confused with that. If you want, I can even change this file. But, I mean, this is a chair model, and this is a chair DAE file, which contains a model, and I'm going to just call it chair. You can call these things DAE file anything you want, and obviously you can call the model anything you want. Now, if you're adding the model to the screen, the first thing we need to do is this is a separate file. We need to get the model out of this file to our own file, to our own scene. So if you go back over here in the view controller, and you will see that right now the scene that we are running is an empty scene. All right. So what we want to do is we want to read the scene from this file. We need to create this file, and then we have to get the model out of this file. Okay, so for that we have to first create the scene. So let's go ahead and say chair scene equals to scn scene, and we are going to use the name for the scene, which in this case is chair.dae. Another thing you should always check is that if you click on the chair.dae and you click on the file inspector, making sure that this is added to the target membership. There is a bug in different versions of Xcode that it not automatically adds that. So always make sure that it is added to the target membership, because if it's not, it's gonna blow up when it's running. Okay, so we got the scene over here, all right, and we can actually force unwrap it. That's okay for now. And now we need to get the chair node. So chair node equals to chair scene dot root node dot child node with the name. And if you remember, we have actually given the name as chair, and we're going to say true to recursively, meaning go ahead and find it in different nodes also, like child nodes. Now this name, the chair, is the actual name of the node that we have given, this one. And you can give it by going to the node inspector, and here it is on the right hand side. You can see that we have given it the name chair. All right. Okay, so let's go back again now, and hopefully at this point we will have the chair node. But now we need to set the position of the chair node of where the person has actually tapped on the screen. Now that position has already been converted into the AR position, the real world position, and you can access it using hit test.world coordinates and so on. So let's go ahead and set this out. So chair node dot position equals to, actually we can actually force unwrap it if you want to. We can actually say over here guard let, and else if the chair node is not found, we can simply just return. We can't really do anything with it. You can throw an error or do some other action. I'm just going to just return it because, well, if the chair node is not found, there's nothing really I can do. So chair node dot position equals to sc and vector 3, and now I can actually go ahead and get the position of the touch in the 3D coordinates, which will be available to me in the hit test instance. So hit test dot world coordinates dot columns dot 3, because we are talking about a three-dimensional matrix, and x. All right, and the same thing we're going to do with the y and the z. So y and z, just make sure that you change this to y coordinates, and the last one is the z coordinate. All right, and once we have the chair node, this chair node is not really part of anything. I mean, this is just hanging around, and yes, it's kind of like part of the chair scene, but we actually want to add it to our current scene view, and we can actually get it using this root node dot add child node, and simply adding the chair node. So now the chair node that we imported or actually extracted from the chair.dae file, we have given it some sort of a position, and then we have added it to our current scene. Now, if you have multiple furniture items or multiple kind of models, then maybe rename this chair.dae to something else like furniture or store.dae, and go ahead and add multiple items over here. Each item will have a different identity, the name representing that particular item, and you can extract those items like I'm doing over here, give it a certain position, and then add it to the current scene view scene root node. Now this is going to give you the ability that your DAE file or your any other file that is holding multiple items can act like a repository, and then you can basically pull different models out of that file and add it according to your needs. So that's pretty much it. Let's go ahead and run it and see it in action. So we'll start by detecting our plane, and once the plane is detected, now I can press anywhere on the screen to add the chair. So let's go ahead and press middle, and the chair is added. And it's resting on the plane, as you can see, but obviously you can't really sit on that chair. It is a little bit in a weird orientation. So let's go ahead and fix that. So you can see that we have successfully added our chair on the plane also whenever we tap on a screen, but the chair's orientation is kind of weird. I mean, you can't really sit on that chair, all right? So let's see how we can fix that. Now, if you go to the chair.dae model, it shows you perfectly fine chair, and you will notice that the camera at the bottom, you can see right here, is set to perspective. Now, if you have been following along this course, I have always told you that it is the front camera that is going to show you how it will render, or the front camera is actually show you how it will look when you actually place an object on the screen without any orientation changes. And if you notice, it is kind of like this. And this is exactly how we see it when we run it into our augmented reality app and we see through our camera. This is the camera we are talking about. This is a camera that is default camera for when we look through our phone. So we need to fix this, obviously. This doesn't really work, right? You don't want the chair to be like this. So what you're going to do is you are going to play around with these Euler angles. And let's say if I give it a 90, that's kind of like upside down. All right, so what about if I give it 180? That's a little weird too. What about 45? That's weird too. So you have to find out the angle that you want to, that will make sure that this particular thing looks nice. And you can play around with these different things. You can see that I'm playing around with it. And once you found the one that you're looking for, and now you can see, so this is basically the one that we want. So let's go ahead and say front. And right now it's kind of like this, right? So if we say X to be like, say, minus 45, let's actually go ahead and play around with it again. Let's go ahead and say front. Is it? Kind of hard to see, but looks like this might be the one that we actually want. All right, minus 45. Let's say if I say minus 90, it's a little bit too off. So minus 45, it's kind of like this. And so this is how it will render now. This is how it will look like when I basically set up or add it to the augmented reality world. And most probably this is what you really want. All right. Now, one other small thing I want to make sure I do this is to add some sort of shadows, automatic shadows. Now, if you have noticed in the last demo video, our chair was rendering, but it didn't really have any personality. It didn't have any colors. It didn't have like any shading going on, which gave it a very pale kind of a look. And you can easily add the default cameras. So you can simply say self.sceneview.enable default lighting true. And that's pretty much it. Now, this is not really a perfect solution, but you will see a difference, a night of day difference, basically, before or doing it like false versus true. All right. And with this setup, let's go ahead and give it another try and run our application. All right, we'll start with detecting the plane, and now we can add our chair. And here's our chair. It's not really right, but you can still see that the shadows and the light is working really nice. So now let's go ahead and fix it again, the orientation of the chair. Okay, so it looks like we are off by a little bit, so we can actually go to our chair.dae file, make sure that this is set to front, And looks like we're off a little bit, so I'm going to change this to -90, and boom, that was it. You can change it by -90 and you can see it's fixed. And I'm going to change the position to 0, 0, 0, 0, 0, and 0. There you go. Let's see. Here is how it actually looks like. It looks really nice. You can also check out the scale. So right now the scale is 1, 1, and 1. If you do want your chair to be smaller, go ahead and set it up to 0.75, 0.5. But make sure that the scale is kind of like same for everyone, because you do want to scale proportionally in the X, Y, and Z axis, hopefully, right? I'm going to leave it like that. I think chair is a little bit big, but we can adjust that later on. Let's just leave it at 1, 1, and 1. If we do realize that the chair is big, we can always go back and make sure this is like appropriate. All right. With these changes in place, let's go ahead and run our app for one last time so that you can see our beautiful chair in action. And here we go. We're going to start by detecting the plane, and as soon as the plane is detected, we are going to add our beautiful chair in the middle of the room. And here it is. Now you can see our beautiful chair being added in the room, and you can walk around it. You can see it from different angles. You can see that the default lighting is really making the chair, giving it more personality. You can go close and far, and that's pretty much it. So we are on to a good start with creating our chair. In the last lecture, we covered that how we can place a virtual object, which in our case is a chair, into our real world using ARKit. And in this lecture, we're going to go over that how we can start scaling the chair, so making it bigger and smaller. Now, the question is, what do you have to do to make the chair large and small, to change in size? And there are many different ways of doing that. You can add buttons onto your screen, and plus button and minus button, but we are already familiar with the iPhone gestures, so we are simply going to use the pinch zoom gesture. So the pinch gesture we're going to use to make sure that we are scaling the object, making it bigger and making it smaller. So let's go ahead and first of all register our pinch gesture recognizer. I'm going to call it pinch gesture recognizer equals to UI pinch gesture recognizer. There we go. And the target in this case is self, and it is going to fire a selector, which in our case, we're going to call it pinched. So P-I-N-C-H-E-D, pinched. There we go. Finally, go ahead and add the pinch gesture recognizer as a gesture recognizer to the scene view. So let's go ahead and do that, pinch gesture recognizer. And now at this point, we don't really have the pinched function, so we need to implement that. So Objective-C, because this is all the selectors, the target action, all these gesture recognizers can actually call only the Objective-C functions, because this is the old legacy code. So we're going to decorate it with Objective-C function and get the recognizer, which in our case is a pinch gesture recognizer. All right. So now we have the pinch gesture. This is where we have to write the code to make sure that our virtual object, which in our case is a chair, is increasing in size and also decreasing in size as we basically, remove the pinch. If recognizer dot state equals to changed, so this is going to get fired. Basically, we are checking that if the state is changing, and the state is changing as soon as you are changing the pinch, if you're pinch zooming it or unzooming it, so this particular recognizer is going to get fired. The first thing we need to do is we need to get the view on which the recognizer is working on. So recognizer.view as ARSCN view. Once again, you can use the guard let over here if you want to. I can actually do that. Guard let, here we go. All right, else return. Okay, now once we have that, we will get the touch point. So we will just call it touch. We do want to get the point on which or where you are actually getting that particular gesture, which in this case is the pinch gesture. So let's go ahead and pass in the scene view. There we go. Now we need to find the point, all right? So this is a little bit different from the tabbed because now the element, the virtual object, is already part of the scene and we need to get that access to that particular virtual object, all right? So hit test results equals to self.sceneView.hitTest, and you can see that we initially used this one, the first one, which is, and we made sure that we are using the result type as a plane, but now we're going to use this because we already have the virtual object right over there in our real world, and we need to get access to this particular virtual object. So we're going to pass in the touch event, and for the options, I'm just going to pass in like nil. We're not going to pass in anything. You can pass in nil. And the same applies over here. So we're going to say hit test equals to hit test results.first, because you might get a multiple hit test if you are selecting different elements or touching different elements. But this one is going to give us at least the first one or one of them. And now I can get access to the chair. So I can say chair node is equals to hit test dot node. All right. So this one, the hit test one that we're using, is different from the one that we used earlier in the tabbed, because in the tabbed we are doing a hit test against an existing plane to find out the horizontal surface, or basically the intersection of the horizontal plane with our finger. But over here we already have the object added, the virtual object added and part of the scene view, and this is basically going to give us a reference to the particular virtual object, which in our case is a chair node. So once we have this, now we can actually go ahead and create the pinch zoom function. So pinch scale x equals to recognizer.scale, because we are doing a pinch gesture recognizer, as you can see on line number 51 right here, which will have a scale property which will represent that how much you are actually scaling. And we will multiply this by the chair node dot scale dot x. All right, so we're scaling in x direction. Now this is a CG float. We're going to convert it into float by simply calling the float function. All right, let's go ahead and build this, and that should be okay. This is only for pinch scale x. We have to do this for the y-axis and the z-axis. Obviously, you will name it differently. So this is the pinch scale y, and we are going to get the scale for the chair node, but in this case, it's a y coordinate, and pinch scale z, and of course, make sure that you are entering z when you are getting the node. All right. So finally, you will get the chair node dot scale equals to SCN vector 3, and you will pass in different kinds of pinch scales that you have found out. In this case, it is pinch scale x, pinch scale y, and pinch scale z. And don't forget to reset the scale for the recognizer to 1. All right. Now we are resetting this because all the scales that we are determining are based on the original scale value, which is 1. All right. Now with these changes intact, let's go ahead and run our application and see the scaling in action. We'll start by detecting the plane. Once the plane is detected, we will add our chair, and you can see the chair actually gets added in the normal size, but we can pinch and then we can actually make the chair smaller, and we can you can see that how the chair is still sitting on the correct placement, and we can actually pinch and zoom again. You can see that the chair, actually the node gets bigger and smaller depending on if we are scaling it, making it bigger, making it smaller, and it works really, really nicely.